Hi, I'm K. Prakash, working as an assistant professor in the Department of Mechanical Engineering. In the lecture series of IC engines, in the last class we have studied about the two-stroke engines and we have studied about the comparison of two-stroke and four-stroke engines. In today's class, we are going to discuss about the wall timing and port timing diagrams. So, what is meant by wall timing diagram and what is meant by port timing diagram? So, this is a construction model you can see here. So, when you see here in this construction model, so here there is walls. So here there is a wall, and when we are moving, so there is an piston. So this is an inlet wall and other one is an exhaust wall. So what happens in the IC engines is, so during the suction, the inlet wall opens, and during the compression, both the valves are getting closed. And then during power stroke also both the valves are closed, and during the exhaust stroke what happens is the burnt gases goes outside. So here if we take the opening and closing of the valves, so during the suction stroke what happens is, so the inlet valve opens, and whereas in the exhaust stroke the exhaust valve gets opens. So the fresh incoming air is coming inside, and then the burned out gases are going outside. So here the opening and the closing of valves is taking place with the help of a gear train and the crankshaft. So now what is valve timing diagram is, so the opening and closing of the valves is theoretically drawn in a sheet, and it is pointed where the inlet valve opens and where the exhaust valve opens and closes. So this notification of the inlet valve and the exhaust valve opening in a diagram is called as a valve timing diagram. So here in the valve timing diagrams there are two types. One is a theoretical valve timing diagram, another one is the actual valve timing diagram. So in the previous sessions we have discussed about the basic terms. So that is TDC and BDC, top dead center and bottom dead center. So in theoretically what we are studying is, so the inlet valve opens at the TDC during the suction stroke and inlet valve closes at the BDC. So this is the during the suction stroke, and in the compression and the power stroke both the valves are closed, and in the exhaust stroke what happens is the exhaust valve opens at the BDC and closes at the TDC. So this is the actual and theoretical difference. So theoretically this is the process, but in real time, so the opening and the closing of the valves will not take place exactly at TDC or exactly at BDC. So there are some advanced, that means the inlet valve may open advancedly before the TDC itself, and also the exhaust valve also will close after the BDC like that. So it takes more time. So what is the purpose? Why this time is taking is, it allows more air fuel mixture to come inside in case of petrol engines, or in case of diesel engines air. Same way it gives more time to send the burnt out gases outside. So this is the actual theoretical and the valve timing differences. So in actual we are considering it opens and closes exactly at TDC and BDC, but in real conditions, in actual diagrams, so it will not exactly open at TDC or BDC. It may be advanced and then it may take some time during the exhaust. So this is about the valve timing diagram. So same way, this same thing can be represented in a port timing diagram also, the same features. Whereas here valves are there, whereas in the port timing diagram there is only ports. So the opening and the closing of transfer ports and all the ports are mentioned in the port timing diagram. So all the stroke suction, compression, power, exhaust is mentioned in a spiral diagram. So in case of four stroke valve timing diagram, so the number of revolutions takes place is 180 degree plus 180 degree, 360 degree, and other compression is 180 degree. So totally we are having 720 degree. So totally we have to draw two circles and we have to mark the inlet valve opening and closings. But in case of two stroke, what happens is, so suction and compression covers, and then this power and exhaust takes place. So this combination of the strokes takes place. So the number of cycles is only one cycle. 180 plus 180 it is 360 degree. So for port timing diagram, it is necessary to draw only one circle. So this is the difference between the wall timing diagrams and actual and theoretical and port timing diagram. Thank you.